reset levels and ensure that we're talking about the same thing when we say ISA. So I'm trying to explain it like we're all five. I actually used this slide recently when I was presenting to a group of patent lawyers. And I think it's a good starting point for the conversation that an ISA is really defining a machine. And hardware engineers will often talk about machines. They'll talk about what is the state of the machine. And when they say that, in terms of an ISA, they're talking about three high-level concepts. What we're computing, so whether or not we're computing arithmetic logic, control flow, where we're doing that computation, whether we're doing it in registers and memories or I/O, and when we're doing that computation, the fetching, decoding, and executing of the instructions. But what we're not discussing with an instruction set architecture is how we do the computation. The example I used for the lawyers was division. If I were to create a standard in RISC-V to do division, that part of the ISA would talk about the opcode and where do the two operands go, what is the code that you use to perform division, discussing things like loads and stores. But what it wouldn't tell you is how to do division. So when you go to build your circuit, you would need to determine the best way to build a division circuit. And this is how I like to start off discussions about RISC-V, the ISA, because it sets everyone's level in terms of separating out the ISA from the implementation. And that'll be really important a little bit down the road. So now that we've level set on what the difference is between RISC-V, the ISA, and RISC-V, the institution, the nonprofit, and we've talked a little bit about an ISA, why would we want a free and open ISA? And answering this question takes me down a bit of a road of just a high-level RISC-V overview. So we'll do a little bit of historical analysis for starters. ISAs are inherently ephemeral. The concept of an ISA generally, historically, hasn't lasted over time. And by that, I mean, if we look at some of the architectures that have existed, many of them have gone away. And I'd like to explore briefly just why a lot of them have. So I start with DEC. I know Professor Aiken and myself and Sri remember DEC. Hopefully a few of you on the call are old enough to remember DEC. There were several instruction set architectures that came out of there. The one that I'll highlight is Alpha. Alpha was a great ISA, and the reason why we don't all program in Alpha, or the reason why many folks had to move their programs off of Alpha, was because the company itself, DEC, went away, and there was no one left to support Alpha. I think it got handed off to Compaq, and eventually was shuttered because of Itanium hopefully taking over for it, which brings me to Itanium. And now that I work at Intel again, I can smile when I say Itanium, because Itanium is no longer supported as of 2020. But it's another great example of an instruction set architecture that if you had written your program for, much like Alpha, you would have had to eventually port it off of that. Not because the instruction set architecture had anything inherently wrong with it, but rather because the companies that were involved in that architecture went away. Spark is a similar story. It has a little bit of openness to it, in that they did try to open Spark up, though to limited success. A similar story with OpenPower. OpenPower was a open instruction set that started as an open platform. The theme that you're seeing here is that companies have play a big role in whether or not an ISA is going to succeed. And by opening up an architecture, an ISA, and allowing it to be governed by a nonprofit, we hopefully remove that possibility of the ISA being linked to a company that's no longer around. The photo I just have, because I have to have a requisite photo of something cute in all of my presentations as per my kids' instructions. Here, I just wanted to talk a little bit about ISA fragmentation. So inherently in building an SoC, you start to run into the possibility of ISA fragmentation. Historically, this has been because no one ISA has addressed multiple concerns. So as you're building an SoC, you might use one ISA for the general purpose compute, another for the graphics processing, perhaps even a different one for things like DSPs, right, radios and audio. or for security, things like TPMs. The key here is that a modular design generally doesn't fit into most business models. And so the ISAs that were developed were not developed to be modular. But this is one of the keys to RISC-V, is that it was designed with modularity in mind. So the goal not being to create a monolithic architecture that you could build one type of processor with, but rather a modular one that could flexibly address different problems. And that leads me to the last point, and that was that ISAs tend to be inflexible. But what I learned, and something that I learned quite clearly working with RISC-V International, was that that's not what customers really want. Customers want flexible ISAs because they want choice. They want to be able to choose between multiple chip hardware vendors. They want to be able to choose between different kinds of licensing schemes, whether they be cross-licensed or open licensed or proprietary licensed. Many customers want commercial cores available, but at the same time, they want to be able to develop custom IP. And they might even want open source cores. They might want core IP that is open, that they're allowed to contribute to publicly. This is another one of the concerns that RISC-V was designed for. And you can see just by thinking back to that list I had of proprietary ISAs that tried to open up, if you're not open from the beginning, it makes these sort of concerns very hard to address. So hopefully in the past 10 minutes or so, I've convinced you that an open ISA is a beneficial idea and can be used to good. And so the question is going to be, all right, well, what is this solution and how do we move forward with it at our companies? This is a slide I use pretty regularly for folks who aren't familiar with open source. I think most of the people on this call are. But the concept here is I often have to highlight, especially for startups, but even for large organizations, how are we going to use RISC-V in a corporate or a commercial endeavor? And while I don't think this slide translates it perfectly, I think it gives the fundamental concept of there's going to be one standard instruction set underlying everything, but what you layer on top of that doesn't have to be open source. You don't have to have an open architecture for your extensions that do security or memory, as the bottom layer shows. It could be commercial or it could be open. And as you move up the stack, right, further from that base ISA, there's nothing stopping you from mixing and matching. I'll pause briefly to say you will need good patent lawyers to explain to you whether or not you can do that. But that small hurdle aside, there's nothing stopping you from developing a chip that's based on an open architecture, but then finding your value add in that stack, creating a commercial solution in that space. And we've already had folks creating RISC-V cores that do exactly that. Sci-Fi is a company that I reference often because they have a vector solution that is commercial. It's based on the open standard of the RISC-V vector extension, but they've created a commercial offering that creates a faster, better performing solution than what you can find in open implementations.
So is this like a case of having an IP marketplace that's open and an IP marketplace that's monetized?
Yeah, I think that's one possible solution. Yes, I mean, taking a step back like you're doing and looking at this more from the community aspect, I think if you have an open ecosystem around a set of, open source IP, right, a set of cores or a set of extensions that are open, it encourages folks to contribute to that base such that the implementation that they're commercially offering is supported upstream in a lot of the software projects they're going to run on. Does that address the question you were looking at?
Yeah, I mean, I was just trying to see if they've made it, if they're actually offering it in that fashion already with, a unified marketplace for these things, or is it still a Wild West where you just kind of have to, figure out your place through the weeds?
Right. Yeah, I think it is. So I don't think the ecosystem is robust enough to me to say that there is a mature open and commercial marketplace you could go to. But I think that's the goal. I think the goal is to get RISC-V to a point where there is a set of cores and extensions that are verified, that are in the open, that people use, and that can be directly traced to specific commercial offerings. So that if you're running a software stack and you do want to try it on a commercial offering to see if the gains are worth it, it wouldn't be as big of a lift as it is today. Ooh, somebody raised their hand. Go ahead.
So I just want to ask, so will this be like the situation with the Linux distros? Like each distro has its own mix and match thing, and each have their own plus and minus compared to the other distros, right? Some vendors provide support, for instance. Is it that kind of thing?
Right. Yeah, I mean, it's tough to make a direct analogy. It's tough to say it's going to be exactly like that. But yeah, I think that's a good way of thinking of it. Distros are sort of a complicated stack to do that with, but I think it's similar to, you could think about how GCC or LLVM and commercial compilers work. If you write your code in C for a specific hardware architecture, that hardware vendor likely has a compiler you can go buy, and hopefully it'll perform better in your workload, whatever you're doing, than the open source solution will. But it is highly likely that that vendor is also contributing to the open source compiler. So sort of taking that concept you had and bringing it down to something a little simpler, I think that's the kind of concept we might see. So moving on from here, I think the slide that I like showing the most in terms of sort of marketing slides is this one. And it's because I joined RISC-V right around 2019, right before that hockey stick looking move in the curve is. So the growth that we saw in RISC-V over the past 4 or 5 years has been pretty impressive. The part that I call out is that if you do some quick math on this slide, 3,000 plus individual members means we have, RISC-V has around 400 corporate, academic, and government members. What that means to me is that RISC-V is succeeding in being an open standard that anyone can contribute to, because individual membership is free. So the majority of RISC-V members today are individual members that joined with no cost. However, there is a strong base of corporate, academic, and government entities that support that, both monetarily and through resources. And the other part that I call out is that it's across 70 countries. I got to work when I was at RISC-V with companies all across the world. So I have a slide here that just talks about some of the stuff going on in APAC. I was really privileged to get to work with some folks from the Chinese Academy of Sciences. They're doing a ton of work alongside organizations like IIT Madras. And the amount of interest and the amount of influence, I think, that you're seeing from academic institutions is exciting, because they're allowed to explore avenues that commercial entities can't explore. The things that IIT Madras gets to try and the chips that they're taping out are things that might not be profitable, but from an academic standpoint, they get to experiment with concepts that I think will end up, many of which we'll end up using in the future. And likewise, whoops, wrong way. Likewise, there's plenty of academic stuff going around globally. I just called out here the stuff going on at Berkeley, but also at ETH Zurich. The academic stuff is being supported by industry efforts that have already been taped out and proven in products. So I just listed 3 industry efforts here. Western Digital's, there are several corporations involved in the open hardware group with the Core V chips, and then Open Titan, which came out of Google, that I'll talk about a little bit more about later in the talk. But these are just examples of how we're balancing the academic efforts with the corporate efforts and actually taping out in chips and putting things in products. And that's happening across the globe. Right. Sorry. Oh, there we go. So I think I've done a pretty good job here of balancing describing the ISA with how we can move the ISA forward and what the current status is. But the next few slides, I wanted to talk about how we can build on that stack and what that stack looks like from a standardization perspective. So here I've drawn out a brief overview of what this looks like. I talked a little bit about the base ISA, about the arithmetic branch, load and store facilities that the base ISA has. But in order to create a product, we need sort of that in-between stage, the microarchitecture, stuff like cache management, TLB, invalidation, platform stuff that I'm sure many of you know of, standardization efforts like UEFI, bus interfaces like PCIe. A question that I would get a lot is, how is RISC-V going to create these sort of implementation details such that we're not all fragmenting and going off and doing it in our own way? And I'll talk a little bit about that. They're called profiles and platforms. And I just want to give a quick example of stuff that's already happened that I think can lead to both products or completely open products. OpenTitan was a project that came out of Google. It's based on a core, the IBEX core, that was created by Low Risk, a nonprofit organization. This core is completely open. You can go and view it on GitHub. OpenTitan itself is an open source project that creates a platform, and one could take that platform and go build two-factor authentication USB key with it. It's essentially a TPM interface. People have used it both in discrete TPMs, and there's actually another open implementation that does an on-silicon root of trust using OpenTitan. But the concept here is pretty simple, right? You can take, if you're able to standardize around this platform concept, then other people can go off and take that platform standardization and build products with it, whether those products are open source or commercial. And so I've sort of detailed out that stack here. The stack, that's correct. Okay, so the stack concept is that you need some base ISA at the bottom, and that base ISA is going to define the machine. And when I say base, the thing I'm talking about is things like opcodes, load store. So all the fundamental concepts of compute. Are you 32-bit or 64-bit? That's going to be at the foundation, and it's going to be open because RISC-V's base ISA is what we're going to essentially build off of. And from there, we have standard extensions. So things that you're likely not going to want to commercialize. Things like multiplication, division, addition, subtraction, things where you're likely not adding value, along with things where you might add value. So things like the vector extension, where folks already have commercial offerings. But from there, we need to standardize even more if we're going to add feature and software compatibility, because that's really what building different products is going to require. It's going to require that we standardize around things, hardware features and software features. And that's kind of where the profiles and platforms fit in. And you can think about how this lowers the bar to entry, in that it's going to be a really heavy lift if you have to take this RISC-V core, build all of this microarchitectural and platform support on top of it, and do it all yourself. Not only is it going to be really hard, but it's going to encourage fragmentation such that each platform is going to need its own spin of whatever software runs on top of it. And so that's where the profiles and platforms fit in. And there's this concept that RISC-V is building around compatible implementations. And the idea is that if we all implement according to the correct profiles and platforms for whatever we're trying to accomplish, whatever we layer on top of that can take advantage of the standardization underneath. And I just wanted to pause briefly to talk about how we know that we're compatible. There is an open source effort to do compatibility testing. So we have base ISAs, profiles, and platforms, but we need some way of showing that some implementation is compatible with that base ISA, profile, and platform. And the way we do that is with 3 separate tools. There's a spike simulator, a SAIL golden model, and architectural compatibility tests. All 3 of these are open source code. The spike simulator is written in C. The Sale Golden model is written in an open language, a formal language that came out of Cambridge called Sale. And the architectural compatibility testing framework is written in Python. And the way you can think about this is the architectural compatibility tests are essentially a smoke test against some implementation that compares that implementation against the Sale Golden model. But that comparison will only make sense if the Sale Golden model is correct. And the Spike simulator is how we test that golden model to assure that it's correct. So I'm not going to go into huge detail here, but the concept that you hopefully are coming away with is that not only are we standardizing these things, but we're providing an open source way to test that any implementation is compatible against it. And I think that's really important, not only for compatibility testing, but for down the road when folks start thinking about verification. I was at a conference recently in France, high performance computing conference, where we talked a little bit about what kind of open verification could we do, and how long would it take to have an open suite of tests against some open core that would be considered production ready. And it's certainly a very heavy lift, but I think that's something that could change the landscape of how people design silicon if they can verify a core with an open source tool set. So moving on from there, I'm going to talk a little bit about how we combine this with oneAPI. And in doing that, I realize I need to address the elephant of the room in that I'm providing one more standard for us to all follow. But hopefully over the course of the next few slides, I can convince you that this is worth it, in that we can take a set of standards that define hardware, combine it with a set of standards that define an interface with that hardware to write interesting software, and that the end result will be beneficial and not just one more standard. So I'm not going to go into detail on specific implementation details of how it could be valuable. I gave a talk a little bit back on vectors on RISC-V. So I'd recommend you start there and continue down the vector rabbit hole, because there are plenty of presentations and documents out there about RISC-V vectors, much more in-depth than the presentation I gave. But I think I see that as one avenue where this could be very beneficial, this combination of an open hardware standard with an open interface standard. But there's more than just vector. There's work going on with the vector intrinsics, there's code size reduction work, and then specific working groups with AI, ML, and security that I think when you look at the oneAPI stack and you add RISC-V to it, there's a lot of value that can be gained there. So let's just take that stack and let's think about how we would add that to the stack that exists in oneAPI. And so this is kind of the high level concept I initially thought of. And it's pretty straightforward, right? Take the thing that I just built. We have our base ISA, our profile, and our platform. Obviously, there's a lot of work that people can do outside that. But if we're trying to standardize with the end goal being the thing at the top, the software, then this is the thing that we want to see in the bottom. But I've already displayed to you all what the problem is. And the problem is it's not going to work, right? You have this very narrow concept across this very broad spectrum of implementations. So today, this is what RISC-V looks like. There really is, from a standardization point of view, there's a base ISA, there's one or two profiles that they're currently working on that are mostly geared toward server class silicon. And then there's one platform that's currently being worked on. But where I see this going in the future looks more like this. And the concept is that they've already said that there's going to be multiple profiles. They're going to need a profile that addresses, that abstracts out the concept of a server class chip. They're going to need one that abstracts out a embedded class chip. And eventually, I would imagine they'll need one that extracts things like the concept of a GPU or the concept of an accelerator. So that's the direction I see profiles going. And similarly, I would imagine platforms will go the same direction. You'll be able to find a platform that fits your specific use case. And I sort of showed that as moving from left to right because I consider that to be where likely the most value add is. They'll probably start over on the left in standardizing and move their way over to the right. So whereas today we really only have RISC-V soft CPU cores, there's not a standardized way to do that, but I would imagine that's the direction we would be moving. So in drawing out this sort of where I hope things go, I've introduced a subtle problem that I'm sure many of you on the call are probably already seeing this, but the problem I'm introducing here is that this is how hardware engineers see the world today. They see the bottom stack and everything about it that's above it, they're really not concerning themselves with. And likewise, on the other end of the spectrum, most software engineers see it the other way around. They see the software stack and everything below it, they really want that abstracted away from them. And so when I'm thinking about how we combine these two worlds, this is the problem I see us needing to address. And that's the reason why I put most software engineers in there, because there are the odd ducks who live right in the middle and who concern themselves with that target system software. And this is the area that we need to be concentrating on today. I'm not trying to say that we don't need to concentrate on the profiles and platforms and standardization of the hardware. That still has a long way to go as well. But I'm trying to guess at who my audience might be here. And I'm imagining a lot of them are going to be these folks that live in the middle, folks that work on things like system libraries, the Linux kernel, the dark art known as firmware, and things like compilers and tool chains. That's the work that needs to be done and really needs to be done in the open and with multiple different perspectives if we're going to create a standardized layer underneath that works for everyone. And when I say different concerns, I really do mean not just RISC-V, right? If we create our firmware in a way that's vastly different than what we did for x86 and vastly different than what we did for ARM, no one's going to like it. They're not going to want to implement RISC-V if the firmware they implement is this completely different beast. So the effort that needs to be done here really does need to bring together the ARM communities, the x86 communities, and create a set of system software that plays to the strengths that we've done in the past. As somebody said in a presentation I gave recently, we really can't reinvent the wheel and fragment with these efforts. So there is a group that's been formed to tackle this problem. RISC-V International concerns itself with the ISA. By very definition, it has to think about these things. However, to try and boil the ocean and do everything would be too much. So there's a group called RISE that just recently announced they're getting started. RISE is going to specifically be addressing the software concerns with RISC-V. And they've already stated that this is their list of priorities to start. I always love it when someone makes a slide for me. And essentially, by going to the wiki, I just copy and pasted their priorities onto this slide and used it in this presentation. So RISE is addressing this challenge. They're a nonprofit that lives the Linux Foundation side by side with RISC-V International. And so those two organizations will be able to work together. But the hope is that RISE can really have a laser focus just on software. And how do we make that software work across the implementations that are being developed? And so I really encourage folks to go take a look at this. I think this is, for those folks who aren't interested in hardware standards, where that's not really where they can add value, from the software perspective, I think this is the place we really have the most work to do. I think this is where software engineers can add the most value. And I think it's the place where if we're going to glue together oneAPI and RISC-V and create an open stack that starts with an open standard and ends with open implementations of software, I think this is the place we need to concentrate on.
So how many, is this, does RISE have, like, you said it's led by industry leaders. So who's leading it today? How many people? Does Intel participate, or does Intel have a seat in this?
Yep. Yeah. So I believe I'm trying to remember the last call. I think it was Mark Scarpness, but yes, SATG, the software group at Intel, is involved here.
Okay.
Part of what I'm trying to accomplish at Intel, as one of the many things, is to find other business units inside Intel that will have concerns here and bringing them to the table. It's a pretty heavy lift to try and, cross BU alignment is a fun concept. But I think the idea is if we can identify the core concerns across the business units and then merge those concerns with other industry leaders. So for example, it's really important that while we do this, we work with folks from Red Hat and folks from other organizations inside RISE. I'm picking on Red Hat because they're one of the folks that came to the table first with RISE. And to me, it's a natural alignment with folks at Intel. And a natural alignment with oneAPI is to work with folks like the distros to see what sort of hardware work needs to be done. And you can go to the RISE project website. They have a list of our members.
Yeah, but I had another question, slightly orthogonal, but when you're in the list of things here, how mature are each of these things today for RISC-V?
No, that's a good question. So I'll pass the buck over to both RISE and RISC-V International because I don't have an answer for you. Certainly not a succinct link I can point you to. But what I can tell you is in conversations with Isaac from RISC-V International and with RISE leadership, that is one of the first things that they need to identify. So if you go to their wiki, you'll see this is their list of priorities. So the first step is find out where they're at today and find out what the first milestone should look like with all of these items. Okay. And I think if you follow the RISE technical steering group, and I would imagine that's where they'll roll up all of the working groups that are bringing them that data. And I mentioned Isaac from RISC-V International because he just joined as the director of software ecosystem. And I know that this is really high on his list of what he needs to do is ensure that RISE and RISC-V International are talking about what's the status of these items. Because the organizations involved in RISC-V International and the organizations involved in RISE need to roll that information up to all their leadership so that their leadership knows, let's just pick on firmware. UEFI, I know, has a long way to go on RISC-V. Can you boot RISC-V using, can you boot a RISC-V implementation using UEFI? Yes. Is it robust enough such that when some Linux distro looks back at the firmware, are they going to see the same thing they do on an x86 implementation? No, absolutely not. So there's a long way to go with firmware. So all of the members of RISC-V International and of RISE that have firmware in their purview need to know what that status is. And Isaac from RISC-V and RISE, that is their job, provide that feedback. That was kind of a long-winded answer, but hopefully that gets to the point of what you're looking for.
Yeah, I mean, it gives me perspective, so that's good.
My next slide is the question slide. So any other thoughts here? All right. If not, I will just open it up to broad questions. My email is at the bottom there. So
I added a link to that the working groups there from RISE in case anybody's are interested to see what the working groups are and who's in charge in the various places.
Yeah, I will note too, getting involved in RISE is relatively easy. Part of the struggle with RISC-V International is that you run into legal hurdles very quickly at big companies. So at a big company like Intel, if you want to go work on RISC-V International, I'll tell you right now, you need to go talk to someone first. You don't get to just join the working groups. And for good reason. I mean, we're talking about developing a standard for hardware at a company like Intel that builds hardware. RISE, on the other hand, is a very traditional way of working on software. And so I think you'll find that the bar for working on software there is much lower. And so the end result is that if RISE communicates well with RISC-V, it'll be a great entry point for doing work. And if you find you need to move further down the stack into the standardization, that's a bridge you can cross when you can get there. And I think I saw a question. Let me see if I can.
Adol has a question. RISE is a working group with RISC-V International or a separate organization?
No, this is a good question. So the way nonprofits work, I sigh because it's complicated, of course. The way nonprofits work, so RISC-V International is its own incorporated entity. It's based out of Switzerland, and it has a separate board of directors and is essentially managed by the Linux Foundation in that. So for example, when I worked for RISC-V International, I actually worked for the Linux Foundation, and my time was essentially contracted out to RISC-V International. RISE is a project that's part of the Linux Foundation. So it has its own board of directors, but the board of directors of the Linux Foundation oversees RISE. And so RISE is connected directly to the Linux Foundation, but it's sort of the conduit by which it can work with RISC-V International. So they're separate entities, but they have that connecting element. And the benefit there, because the first question most people ask is, well, why did you do it that way? Why not just have this be part of RISC-V International? Well, if you think about how the Linux Foundation works, the Linux Foundation houses, much like Eclipse or Apache, it houses a ton of different open source efforts. And so by being a part of the Linux Foundation, RISE has access to all those other projects by connecting directly with a lot of their program management and leadership staff. So it was kind of a natural fit to put the software bit directly under the Linux Foundation and keep the standards under RISC-V International. And that's a great question. It's how does oneAPI fit into the RISC-V software ecosystem? So, I mean, short answer is today there is no direct connection. The slides that I showed are essentially where I'd like to see things go. But because two big things in the way here. Thing number one that I'm sure all of you know, there's not enough RISC-V hardware out there today. RISC-V suffered from the chip shortage more than most folks because the implementation is new and a lot of the folks working on RISC-V implementations are startups. And so the chip shortage and the supply chain issues hit them particularly hard. But the other reason is because RISC-V is inherently a very nascent architecture. And so there just aren't as many implementations out there as ARM x86. So I think the hardware shortage is one reason, but the other reason, even as we see more and more hardware implementations out there, the reason why there's not an easy way to fit oneAPI with RISC-V today is because of that last slide I showed, where there's a list of system work that still needs to be done. So if you were to build a stack with oneAPI today, the real weak point is going to be that system software, and that needs to be shored up first before products make sense. The reason why I see it as extremely valuable and worth the work is because you're creating an ecosystem where the openness of the implementation starts all the way at the bottom and works its way all the way to the top. So that means the resources that can be put to bear on those problems grows exponentially. You're no longer one company trying to work on UEFI for RISC-V. You're a dozen companies trying to work on UEFI. And as you roll up the stack into oneAPI and say, all right, well, how do we get, oneDNN, or how do we get SYCL working with RISC-V with this specific RISC-V implementation? It's no longer one company doing it. It's any company that has an interest in SYCL and a RISC-V implementation. And my hope is that we see more open implementations such that companies are working together on it in the open, because I think that's where the real value add will be.
Yeah, but especially since it's a wild west right now, and companies are trying to mark their space here, it's very unlikely you're going to get the collaboration you desire. So it has to be an objective third party that's going to do it.
Right. No, I agree that it's a very high bar. I think what we'll likely see is collaboration on commercial efforts at first. But I think when you do get that organization that's willing to take that chance and create an open implementation, I think you'll see I think you'll see several attempts at that. But I would imagine farther down the road, if someone were to succeed at that, that would become a very attractive platform.
I was looking at the runtimes, language runtimes work group, and it's interesting. They target Java, Python, Go, .NET, and Android runtime, but not C or C++ or anything. What I would see is traditional or maybe flexible, I guess,
Right.
to my.
So yeah, part of the reason. So the two pieces that you bring up there, Sri. So one is, if you want to know why Rise is working on what they're working on,
Yeah.
go look at, I mean, eventually you'll know because you'll go to the working group meetings and you can probably
I will
it that way.
Yeah.
But just from a high level, look at who the members are at RISC-V, at Rise, and think about the concerns of those organizations, because they're the ones providing resources. So when you see Google as one of the members of Rise, and you see LLVM and work in Java as one of the main efforts and goals, you can kind of put two and two together and understand why, from an Android perspective, that might be attractive. So there's sort of that piece. But the other piece is that from a C perspective, I'm going to have to hark back to the hardware issue. If you're trying to optimize C code, you're going to have to do it for a specific implementation. And those implementations currently aren't open. So you're not seeing an open organization optimizing for any one particular platform. But I think as platforms become available, so just as an example, right? A lot of the conversations I had when I worked at RISC-V International with Red Hat and with SUSE and with Canonical were around, when can you ship me hardware? And so I think when you start seeing a server-looking platform become available and RISC-V International starts shipping that to Red Hat and SUSE and Canonical, I think you'll start seeing a lot of work being done on GCC and LLVM, specifically for C and C++.
Well, certainly hardware availability is a good reason. I would assume from a compiler perspective, a lot of that is going to be immature at first,
Right.
Especially if you're generating RISC-V instructions and optimizations and so forth. So there's definitely a long tail here on maturity, at least from the ecosystem.
Oh, and somebody brought up the Milk 5 Pioneer. So I am excited to see someone building a desktop-looking board and platform. That's exciting. I would imagine, knowing what I know about that implementation, I would imagine that the folks in the distros will be excited about that and will work on it. However, you need something much more robust from a standards perspective. So you need something that implements the latest vector extension. And to be fair to them, the standards need to go a little bit further before you build something that is really interesting from a distro perspective. And one example would just be the security stack, right? So there is no equivalent of SGX or Trust Zone for RISC-V yet. And until there is, that will limit how useful a RISC-V platform is to the distros. That's just one example, but a ton of other examples in the stack. Other questions?
I'm actually excited about a desktop based on RISC-V. Of course, given my background, some of you may or may not know, I've spent 30 years at least in desktop or application stacks, open source, free software stacks. So it's always something close to my heart, is able to see a completely open system from hardware, firmware, all the way up to application stacks. So I have another question. Adel says, oneAPI is meant to be an open source collaboration, not just a commercial solution for Intel products. Absolutely, it is intended to be an open source collaboration because they're based on specs. So if you look on github.com/oneAPI-source, you'll see open source implementation of the spec. And the specs are also based on open governance. If you look, we have a forum and that decides what those specs are with a set of folks. And just like RISE, there are working groups and so forth.
Nice. Well, I put my email at the bottom of the slide, so feel free to reach out. And yeah.
So I've got a question for you. Just thinking about kind of the call to action here and kind of referring back to some of your other comments as well. Being back at Intel for 3 weeks now, what do you see as kind of the next steps now? What now?
Yeah, it's a good question. So part of what I'm trying to gather is what, aside from that system level software that obviously is going to stand in the way, what are the end-to-end solutions that make sense? And I think that's a question that has two parts. One, what is an end-to-end solution that makes sense from a monetary perspective? Like, what's going to be beneficial and that people can actually make money doing it? But then the other one is what can be successful as an end-to-end solution from an open perspective, an open source perspective. So I'm looking through, keep in mind, I am by no means a oneAPI expert. I am here painting my rosy picture of how we might bring together RISC-V and oneAPI. And I say this as not a oneAPI expert, speaking to a bunch of oneAPI experts. But my hope is that I can bring a different perspective and think about, knowing what I know about open source efforts and open communities, what end-to-end solutions could get the most traction if we put work behind them. And I think that's what I'll be focusing on in terms of oneAPI and RISC-V going forward.
Great, thank you.
Any other questions? All right. Well, you've all got my email.
This might be a naive one, but when do you see RISC-V to get mainstream adoption? Like in 5, 10, 20 years?
Sure. No, that's a good question. It's pretty, in terms of where they've achieved it already, I think they've achieved mainstream adoption in the microcontroller areas. So if you look at companies like Western Digital that have moved a majority of their microcontrollers over to RISC-V instead of ARM, that's one place that I think they're succeeding. But in terms of the other two, the thing I'd say is take a look at how long it took ARM to go from an embedded platform to something that could be used in the server space. And that'll give you some idea of how long it'll take RISC-V. I hope it'll be shorter than that, because I hope that it being open will make it easier. Awesome. All right, well, feel free to email me. I know we're reaching the top of the hour, and I really appreciate folks coming. This is very early on a Friday for folks here on the West Coast with me, and for the rest of the world, I know you might have already started your weekend. So I appreciate you coming, and thanks very much.
I will add that I will have the link once it's finished processing. I will have the recording available. I will post it on the Meetup chat and probably in various other places. So thank you, Stephano, for your great talk. It was really interesting. And I thank for the rest of you for attending. And I hope you have a wonderful weekend. And please do, if this is your first time at the Meetup, I'd love to hear any feedback. What kind of talks you'd be interested in? Last time we had some great, another great speaker. So it looks like I'm filling this with great speakers, and I'd love to keep driving with more speakers that interest people. So once again, have a great weekend, and we'll see you next time. Thank you.
Thanks, everyone.
Thanks.
Take care, y'all.
Bye.
Thank you.